So we had a little change of plans of how we were going to break down this first week. So this video is actually only for the remote students. I think today is going to be Monday when you're looking at this. This is your in-class lesson. So this is what we are doing in class while you guys are at home. So you can watch this video, skip through things that you don't need to watch me do. I think I did a couple of really basic factoring problems just to kind of get myself back on track as well. So, work through those first couple if you need to. There's a couple new strategies factoring some of the difference of cubes that I need you to look at. Watch the video. You can try a few of the problems that go with it on your note packet. But next class, when I see you, that's when we can really ask some questions, go through some of these together. But I'm going to post the answer key to all those problems up online so you can check your work if you want to try a couple of them out. But your only classwork is to watch the video, and then there's going to be, I don't know yet, 1 or 2 Delta math questions that I'm going to assign that goes with it. All right, so try as many or as few in the note packet as you want, just for some practice after you watch the video. Couple Delta math questions so that I know that you did it. And then any major questions that you have, you can come to office hours on Wednesday. You can come to any activity period, or if you are live in person on Thursday, I will talk about those then. All right. And then you will also have kind of our first official homework assignment tonight as well. So I'll be very clear laying that out in Google Classroom. But this is your classwork. Let me know if you need anything, guys. And I will, I'll see you soon. Bye. All right, guys, this is our first video of the year on factoring review. So I want to do, a little bit of review of stuff you learned at some point last year, whether you were in school or not. So these are 3 tools you've used a million times. I actually have kind of a neat way to factor these trinomials where a equals 1. If anyone's interested, we could talk about that in our little class sessions. We're going to have some time to practice. Where usually we're looking at, what will add to this, b value and what will multiply to the c value. So we're thinking, all the basic factoring you guys have done a million times. X squared minus 5x, minus 6, whatever, something like that. So we're multiplying to a -6, and we're adding to a -5. So those would be -6 plus 1. Not that I need to go over this with you. Teachers back in Algebra 1 might have done it with the Windows method, where we have x and x. We have -6 plus 1. We check our work that way. So that's just real basic reminder of how we're going to do our factoring. Not that you really have to take notes on that. We also have the situation where the a value is not equal to 1, and we have to do a little more guessing and checking there. That 3 out front is going to skew things, as you obviously remember. But in this case, I had that factored for you. But that's going to multiply us to the -1, add us to the +2, and that's how we'll factor this expression. Difference of 2 perfect squares is something you've looked at a million times as well. This is just a pattern that you should identify at this point. So we have like 9x squared minus 49 or something like that. We should see that and just kind of intuitively know we have a difference of 2 perfect squares situation, and that's what we're left with. All right, so if you need to pause, like we talked about earlier, pause, rewind, rewatch, whatever you have to do, skip through if you need to for some of this stuff. But that's our real basic nuts and bolts of some factoring. Other things you've looked at is factoring by grouping. So this is kind of one of those situations, if it's a perfect world, this is all going to be lined up nice and neatly for you. And you say, well, there's 4 terms. I see something cubic out front. So this is a little different than the situation we just talked about. And if things work out and really nice and neat and tidy, we can look at this as a factor by grouping situation, where we can group these first 2 terms together. We can group these second 2 terms together. And if this works, we should have the same term in the parentheses. So let's see if it works out. So let's see, we have plus, and we can also factor a 3 out here, and we're left with 3x minus 4. And sure enough, that works out nicely. So what we really have here, if you kind of go back to the basics, go old school here, we have windows. We have an x squared plus 3 term here. Whoops, I put that in the wrong spot. And then we have this 3x minus 4 term here. So if we were to put this all together, we would end up back with our original expression. So the one thing people kind of get caught up on here is that they try to turn this into 3 terms. But this factor by grouping, like I showed you here, it's just a window. It's just a 2 by 2. So what we have here is x squared plus 3, and then 3x minus 4. So that 3x minus 4 doesn't show up twice. All right, so there's our factor by grouping approach. All right, last strategy. You may have talked about this a little bit, but sum and difference of cubes. So sum and difference of cubes should begin to look as comfortable as a difference of 2 perfect squares. You should see this and you should identify right away the pattern. So if we have cubic terms here and here, the a and the b that I'm going to show you in this formula are the cubed root of those 2 terms. And that'll be important in just a second. So the pattern here for this sum of cubes is a plus b, a squared minus ab plus b squared. So a plus b, a squared minus ab plus b squared. So the pattern here is plus minus plus. Those 3 terms together, plus minus plus. So now all we have to do is put them into our formula. So to factor this x cubed plus 27, let me get these out of the way. We need to think about what our a and our b terms are. So the a in this case is just the cubed root of x cubed, which is x. The b is the cubed root of 27, which is 3. The sign here doesn't matter. So if this was a minus 27, it wouldn't be a minus 3 here. All right, that's all built into the formula. So now when I put it together, it's a plus b, so my x plus 3, and then we have a squared minus ab plus b squared, 3 squared, which is 9. So if I were to multiply this all out, I would end up right back where I started. So that's a really good way to check your work if you were to multiply this all together. So there's our answer. There's our sum of cubes. Now the nice thing is the difference of cubes. We still have our a and our b. The difference of cubes is the same pattern. All that changes, I'm going to write this over here. Instead of plus minus plus, it's minus plus plus. So minus plus plus. So our difference of cubes is a minus b, a squared plus ab plus b squared. All right, so there's your pattern there. Now be really, really careful. I put this one in here on purpose. My first term, my a term, is this whole thing. All right, so the cubed root of that first term, it's not just 8a, right? It's the cubed root of that entire quantity. So my a value, when we put into our formula, is going to be 2a. And my b value, I mentioned this before, it's not negative 5. It's the sign here doesn't matter. We just look at the cubed root of our b term. So the cubed root of 125 is just 5. All right, and the signs, the pluses and the minuses, all work itself out in the formula. So I look at this, I say, oh, okay, this is a difference of cubed patterns, difference of cubes pattern. My a value is 2a. So the first term is just a minus b, that's a piece of cake. A minus b, careful here, this whole term squared. So it becomes 4a squared in my formula. So it's a squared plus a times b, right there, plus b squared. And again, you could multiply that all the way through and check, and it should get you right back to the original. All right, so those are 2 formulas. If you've never seen them before, they look crazy. You'll get the hang of them pretty quickly, I promise. So there's our 2 new formulas. All right, and also in your note packet here, I have a couple things just to keep in mind. Always begin by factoring out the greatest common factor, right? If there's something, if there's an x in every term, if there's a 2 you can factor out, that's always going to make your life easier if you factor that out first. And I'll talk about one of those in a minute. When multiplying factors with a common base, so let's say we have x squared times x cubed, we add the powers. We add the exponents. And then something else that will be very helpful to keep in mind, the square root of x, to change that root into an exponent, it becomes x to the 1/2 power. The cube root of x becomes x to the 1/3 power. The fifth root of x cubed becomes x to the 3/5 power. So that's the numerator of your exponent. The root is the denominator of your exponent. Okay, so those are the kind of things, if you feel like you just have not had enough practice with them since last year was so weird, those are some things we can talk about in class. Okay, so in class, remote, I'm not exactly sure what I'm going to be assigning you guys, but you have a whole ton of examples to practice. So at the very least, I'll make it clear when the time comes. But for now, I think my plan is to just have us practice a bunch of these. I will put an answer key online. I think you have 2 pages worth. But I wanted to look at number 5 together. Number 6 is a little bit challenging, so we can talk about that one when the time comes in class. You guys can talk with each other or ask me. This one's a little bit different because we have this negative exponent. So really quick, just a nice way of thinking about this. You're going to hear me say this a lot this year. If you're stuck on a question, go back and look at something that you're more comfortable with, something more basic. So if I have something like this, x to the 4th plus 2x squared. First thing I want to look for is a GCF. So I can see both of these terms have an x squared in them. So we know we're going to factor out that x squared, right? What do I have left in this first term? I mean, we all probably know by looking at it, we have an x squared left. But what we really did was we divided out this x squared. And when you divide common bases, when you divide their exponents, you subtract them. So let's say this is, actually I like this better. Let's say that was an x to the 5th. What we're going to have left here is an x cubed, right? We just subtracted out, we divided out that x squared term. So x to the 5th, divided out x squared from that, leaves us with an x to the 3rd. So we subtract the powers. And then what we have left here, plus, the 2 stays, that coefficient doesn't go anywhere. And we subtract the powers. X squared divided by x squared, we subtract those numbers, leaves us x to the 0, which is just 1. So keep that in mind, that idea of subtracting the powers. So when I look at number 5 here, I have this negative 1/2 power. So rule of thumb is we always want to factor out the smallest power. So in this case, that smallest power is the negative 1/2. So let's think about this. I have an x to the negative 1/2, and I'm dividing out, I'm factoring out, I'm subtracting the negative 1/2. So I have a negative 1/2. I'm subtracting or dividing out the negative 1/2. So we have negative 1/2 minus a negative 1/2. We think about that turning into addition. We're left with 0. So we're left with x to the 0 power here, or I guess I should say 1x to the 0 power. So we just are left with a 1 there. Now my second term, I still have my coefficient, my 2 there. So now we have 1/2 of an x here, right? We have this 1/2 power. So let's think about that again. I have x to the 1/2. And actually, I'll just write the power here. We have a 1/2 power. We're subtracting or dividing out a negative 1/2. So just like I did here, I started with a 5. I factored out or subtracted out 2. That left us with 3. Here I have a 1/2. I'm subtracting out the negative 1/2 that I factored out. So I'm actually left with, we add those together, we're actually left with 2/2 or 1. So my second term stays as an x to the 1st, or just x. Now same thing for my third term. We have 3/2 of an x here. We have x to the 3/2 power. We're subtracting or dividing out that negative 1/2 power of x out front. 3/2 minus a negative 1/2 is 4/2, which is a squared power. So my last term, I have 2 x's left. So I have x squared. So when we're factoring out anything, whether it's a nice easy integer like this or whether they're fractions, we're thinking about dividing out or subtracting those powers. So something kind of neat happens here. We can actually rearrange this to get the leading term first. And we can even go a little farther with this factoring, but I'll let you do that on your own. So keep that in mind when you're looking at number 6. But those are the nuts and bolts of factoring. When I see you guys in class, those Wednesday live Zoom office hours, these are your opportunities to come and ask questions to me. We can go through anything that's giving you trouble. Okay, so here we go. We're off to a good start, hopefully, and I'll talk to you guys soon. Bye.